Hello everyone, this is Ashish and welcome to Spacecast, the podcast on space technology. And we are just going to start. This is the first episode. And after the good success of the Momentum podcast and the Talk and Fire podcast, I think I should definitely start a podcast in space domain. And I've been planning to do so for a long time. In other videos that I've made on space technology and Kerbal Space Program, I've said that maybe there's no space podcast available. I was proven wrong by someone in the comment section by saying that Neil deGrasse Tyson is already having a podcast on this domain. I think the name is Star Talk. And I researched it, and it's bloody old. It is like 7 to 8 years old. It has been there for a long time. It started as a radio show, and this one is going to start in this form. And I'm definitely not an astrophysicist, but I have experience in rocket science, especially being a part of ISRO for some time, over a year, somewhere around half a year ago. So I have a huge interest in space technology, and I have knowledge also. I continue to study about various space technologies and orbital mechanics and everything that I can study about space science. Continue to do so, and I'll be happy to share information over here. So I'm pretty sure that you are going to love this one. Now, this is how we do, at least this is how we are going to start. That few of the topics that you put as a suggestion in the comment section or in any post, then I'm going, or you can DM me or you can tag me somewhere. I go through those questions and I discuss it over here in the podcast. Over time, we are going to have guests also, so that we can have a discussion, a talk kind of. But I'm having a lot of topics that you guys suggested, a bunch of them, and definitely I can cover a long time talking about those things. But the most important one, and that made me just say that I'm going to record that podcast right now, is Skyroot. Someone said in the comment section that why don't you talk about the Vikram rocket of the Skyroot? And I said that Vikram rocket, let us study a little bit more about that. And then I got into Skyroot, and then I went into their website, and it is bloody interesting. You're going to very soon. Why? I'm going to show a little bit of the screen. If you're listening to the on audio version, then the video version is available on YouTube. But if you're here, then you can see the screen. Otherwise, everything I'll be explaining anyways. Now, if you go to the website of Skyroot, it is actually Skyroot Aerospace. And a few people might have heard there's another organization, private firm named Agnishul, and they were also working on cryogenic engines, semi-cryo engines. And I watched few of the interviews of those people, but I do not know how it is going on right now. I know that they are based off of Madras. They are working a lot in IIT Madras, and don't have much information, but I got few of the top people over there, the email of them. Maybe I'll contact them, try to find out what's up over there. But about Skyroot, this looks hyper professional, and I think that they are working with ISRO, and especially because it is made by a lot of former ISRO scientists, a lot of retired ISRO scientists, a lot of founding members of ISRO. So let us find out a little bit. It's not that I did a lot of research, but just by looking at their website, it seemed extremely interesting. Democratizing space. Nice. That is their motto. A new space age is emerging in extraordinary. Okay, basically the whole privatization of space sector. So a lot of people might be saying that ISRO is getting privatized. ISRO is not getting privatized, but ISRO is going to shake hands with a lot of private partners, just like NASA is doing with SpaceX or Blue Origin, and it's going to grow faster. It's going to help the space program grow faster in this country. Now, India has proven a lot in the space domain, coming up so far and becoming the top 5 space organizations of this country. It is definitely incredible. But I think one thing that was holding India back in the space domain is that we are not encouraging the private sector to work over there. For example, a lot of rocket engines of NASA is actually being made by Boeing, right? The private sectors are working with the government sectors, and that is definitely going to help both of them, right? And you're going to grow much faster. Why does NASA say SpaceX, or why does NASA gives a lot of projects to SpaceX? Because they know that NASA is a government organization. It is going to be slow. Not only that, because the organization is so humongous, it's going to take a large amount of time for the same thing to be done, when compared to SpaceX, which is just a private organization and just started in 2002 or something. right? So it is definitely going to help both the parties if you do it like this in a collaboration manner. Now it is having the launch vehicle named Vikram. So they have already planned Vikram 1, Vikram 2 and Vikram 3. I've heard that they are going to have their first launch somewhere in 2021, and Vikram, most likely they have named it after Vikram Sarabhai. You might be knowing that they did similar thing in Chandrayaan 2 also, named lander as Vikram. So huge honor in all the space organization has to go to Vikram Sarabhai. If you specially study the history of ISRO and how ISRO came into being, and how actually Indian Space Research Organization at that time, Incropar, was actually a part of Department of Atomic Energy, and later it separated from Department of Atomic Energy and got its own Department of Space. And Vikram Sarabhai, although did not actually see the rise of ISRO, he was unfortunately not alive to do so, but definitely he would have imagined the picture that we are having right now in India with the space program going on in ISRO. So they have given the respect over here by giving the name of their launch vehicle as Vikram. Now let us study. This is extremely interesting. The people who are the founding members of Skyroot are extremely interesting. Like more than half of them are from ISRO. Okay, now Pawan Kumar Chandana, co-founder, CEO and CTO, former engineer in Vikram Sarabhai Space Center, that is VSSC, which is in Trivandrum, worked at ISRO in the capacity of system engineering of world's third largest solid rocket stage and deputy project manager of latest launch vehicle project. Okay, he's from IIT Kharagpur. I'm not exactly able to understand how old is he or how much work experience he has as an ISRO scientist, former ISRO scientist. Let us find a little bit about Pawan Kumar Chandana. He looks extremely young, but still I'm going to do a little bit of research. He was in VSSC, which is, if you do not know what is VSSC, it is the primary research portion of ISRO, and it is again named after Vikram Sarabhai. The full form is Vikram Sarabhai Space Center, right? And all the aerodynamics, mainly that kind of research goes over there, and there is a huge solid rocket motor research going on over there also. Matter of fact, the Rohini rocket, or the small rockets that are built, which is having only solid stage, a lot of them are manufactured over there itself, right? So maybe he was involved in solid rocket over there. Okay, he is having a TED talk as well. So I'm going to do more research over there in later phases and find out. He's looking young, not more than 30 35. I do not think he's older than that, but this is not completely on. I'm going to do more research on Skyroot and find out who these people actually are. But one of these people specifically, I've actually attended his lecture. Okay, I'm going to talk about that later. The second is Naga Bharat Dhaka, is co-founder, COO, head avionics and GNC, former flight computer engineer at VSSC, Vikram Sarabhai Space Center, ISRO, designed and realized multiple avionic module for launch vehicles. Leads the avionics and GNC team of Skyroot. All right, so he's also young only. Now this one is definitely not young, and he is actually retired ISRO scientist. V. Nan Gandhi, right? And I've attended his lecture during I was a part of IITP 32. Our ISRO induction training program went from October to December, and he gave a lecture, and he's a fantastic speaker, very experienced. I think these are the people who joined ISRO somewhere around 1970s. I do not remember. I have to take out my notes, and definitely there's at least 4 to 5 pages of this gentleman over here. He also worked in solid motors also, most likely because at that time solid motors were developing. So Padma Shri awardee, yes, he's Padma Shri. I think at least 3 to 4 Padma Shri awardee people came to our IITP to give lectures to us. A pioneer of cryogenic rocket engine in India. I think as far as what I remember, he was a part of technology transfer of Vikas engine, that is the first primary liquid stage of ISRO that is used in PSLV rocket. So that would be the first liquid stage. It is an Indian version of Viking engine, right? So he was part of that, actually the head of that, to get the technology transfer. And then the second time, he was also a part of technology transfer of the cryogenic engine from Russia. All right, so he's a very, very senior scientist, actually retired and very experienced person, right? And if you look at it, he was a former director, quality and associate director, liquid propulsion systems center, that is LPSC, ISRO. That is also present in Trivandrum only. The place they call as starts from V. I'm forgetting. Extremely sorry. Okay, but yeah, it is in Trivandrum only. I'll put it on the comment section. I'll put it over here. But that is not that important. But yes, he is a former ISRO scientist, and he has done his part, like 30 to 40 years experience in working in ISRO, actually having experience of founding ISRO to a huge extent, all right, building it by his own hands. Mukesh Bansal, member board of directors and advisors, technology entrepreneur and investor. Okay, now these people will be more of a business side people, management people. Amardeep, okay, again, BE Aerospace UK, alumnus of university. Okay, so I want to study a little bit more about their launch vehicle. I'm going to get over there. Rest of the people, former distinguished scientist, chief controller, DRDO. Okay, they are having people from DRDO as well. Dr. A. Subhananda Rao. And this one also, this is also former deputy director VSSC. He's a former DD of VSSC. ISRO, held responsible position like associate project director avionics. Okay, human space flight program. All right, so basically this is a great team, and this is probably the reason why it is doing so well. Now there are other people also. S. Watsal worked in ISRO and DRDO. So basically they are not playing around. They are bringing the top scientists of ISRO. They are having some young blood as well, and then they are having some old experience as well. All right, extremely interesting. Now we are going to look at the launch vehicle, what kind of launch vehicle they are having. They are having again the way SpaceX went, right? So first they are going to have the same body, and then they are going to increase the thrust, having some boosters. All right, so Vikram 1, I do not think that they are giving proper like what kind of engines they are using. Is it only solid boosters? Maybe. All right, Vikram 1 payload 225 kgs, 500 kilometer SSPO. SSPO stands for Sun Synchronous Polar Orbit, and 315 kgs at 245 degree inclination, 500 kilometers low Earth orbit. All right, so you are having somewhere around 0.3 ton that you can carry with Vikram 1, and this is actually completely made of solid stages, highly reliable solid propulsion stage with proven design heritage. Now you might be thinking that what is this complete solid stage? I've talked about solid stage. So basically none of the stages will be made of liquid engines, right? Now ISRO is also thinking of developing something like this, like all the stages will be solid. This is actually useful because you can have instantaneous launches. Now within a day a launch is ready. For small satellites it will be helpful. So small satellite launch vehicle, yeah, SS will be. ISRO is also developing something like this, and I think the whole development is going on in VSSC area only, and they will be having maybe a different launch pad for that than Sriharikota. Okay, now it is looking very, very similar to that. Okay, the Vikram 1, it is also having all the stages as solid stage only, and it is also catering the small satellites domain only. And other see what happens. I've talked about this before. Solid stages can be stored for a long time. All right, so what happens with liquid stage, you can have the engine, but engine will be empty. You cannot fill it with propellant, right? But solid stages are ready, but the problem is that it is not controllable. So if the trajectory is simple and you can just launch it, so it will be launch ready for that. Orbital adjustment module and restart capability enables multi-orbit insertion. So most likely the topmost stage must be liquid, maybe monopropellant engines. So they have not clearly said what kind of engine they are using. For example, if you go to ISRO website, everything will be mentioned properly. Every stage will be told that this stage is made of this. So I do not even know how many stages are there. The only thing that I can guess is that when I go to Vikram 2, then they are saying 410 kgs to 500 kilometer SSPO, and then 520 kgs to 45-degree inclination, 500 kilometer low Earth orbit, right? And then they say that advanced cryogenic Methalox engine replaces the third stage of Vikram 1. So at least it is having 3 stages. So most likely, if I have to guess, then it will be having 3 stages, and the last stage is the third stage. Methalox engine is a cryogenic engine that the Raptor engine of SpaceX is also similar only, right? So they might be going in that direction. Why do we need a liquid stage in the last stage? So that you can adjust the orbit properly. You can start and stop the engine. You can adjust the thrust accordingly. So they have not talked much about the engine, most likely because it is still in the developmental phase. Maybe they are not ready with that yet. But I hope that we get the information soon. If you have any more information, put it down in the comment section. We can discuss that as well. All right. So rest of things are same only. They're not giving much of an information. Then we look at Vikram 3, and it has the capability of having like 0.7 ton, close to 1 ton capacity. If you do not know, like the strongest launch vehicle of ISRO would be GSLV Mark 3. It is having a capability of going up to like 4 ton. All right. So ESA and all with their Ariane rocket can go up to 10 tons. So it is still in a very light satellite domain only, and they are still in low Earth orbit only. Let us see what more information we can get about this. But this is definitely very, very interesting. We are not getting much of an information over there. Only, yes, we are planning about 3 different launch vehicles, and we are having these as the founding members, and they are giving some social media handles. So let me see if I can approach them. And some of them actually wants to come and talk to us on this podcast. Let us do that. It will be very, very interesting. I think that I can approach a lot of them. I'm having contacts in VSSC, so let us see that if I can build a contact. So that Agnishul, I got a contact through a friend that was there in IIT Madras, but I never actually used it properly. I think now is the best time to talk to these people about the new space age of India. How is it going to be? All right. So yeah, I think this topic of discussion can end over here. And let us see other questions that you guys have left. I'm having a very good set of questions. I said that I'm going to answer the 10 questions that Global Feed has asked. So definitely that is going to be answered over here. Where were the questions again? Let me see. 1 second. All right. So this question, you can take the topic of making new Vikram rockets by Skyroot Aerospace or SpaceX Starlink mission. Okay, I'm going to talk about SpaceX in the next one. But this question was from Anindya Sinha, sorry. So thank you for that, Anindya. Thank you. That was a very good question. Made me find out new things about what is going on right now. All right, next question. Without wasting time, let us get into Global Feed's question. What's the shape of universe? So I've answered this in a short form during my talk. I think it was a momentum podcast, but I can explain a little bit more over here. I said that universe is having no shape because it is infinite, right? So what is the edge of universe? Can you think about that? What do you think is the edge of universe? Well, it is again a relative term. The edge of the universe, according to us, would be the part which we can actually see regardless of the time. So what do I mean by that? So you know that to see something, you need light to reach to you, right? Now, universe was born at a particular time, you know, the Big Bang Theory and all that. It was not always present. And that is, again, another interesting topic that we might be talking about someday. But the edge of the universe would be the farthest point from which the light has actually reached to us. So it is going to take a large amount of time for light to travel, even though it is so fast, 3 into 10 to the power 8 meter per second. Still, For the gigantic size of the universe, it is going to take a lot of time for the light to reach. So for the amount of time for which universe has been existing, since that time, whatever is the light that has reached to us, even if we build the strongest telescopes and we are able to see the farthest point of universe, we are only going to be able to see the portion which is having sufficient time for the light to reach to us. Was I clear about that? So that would be end of the universe for us, but still, even if we try so hard, there's a limitation of how far of a universe we can see. But it is infinite, like we have said before. So something which is infinite cannot be given any shape. All right. So it is having an infinite shape, I think. Okay. Next question. If an astronaut wants to scratch his head when he is in space, in a spacesuit, I always mess that up, how he can? He cannot. All right. He'll actually have to get back into the spacecraft, remove the helmet, and then scratch his head. I talked about this. Chris Hadfield actually talked once about his first journey to ISS, and when he was in orbit, he went out for a spacewalk, and then something got into his eyes. So apparently, even the tears that you are having in space will not be able to fall down. It is just going to clog up over there because there is no gravity. Actually, there is gravity, but you are actually falling, right? So when you are in orbit, you are actually falling. So you are falling and your tears are falling. So basically you are both going to be stationary in respect to each other, right? So he talked about that. It is a very interesting TED talk. I suggest you all to go through it. Over there, he basically talks about that a common person might be thinking that it would be so nerve-wracking for a person to go into space and then come back to Earth. But he said that it is just like you do anything. You do more and more of that and you'll become accustomed to that. And we trained for it for years, and we had good experience, and we had simulations going on. And when we actually had to do it, it was nothing. It was just like any other job, right? So it was very, very interesting. You should definitely go through it. The third question is, what is the end of space and Earth? This question I answered properly. For us, the end of Earth would be the death of sun. So whenever sun runs out of energy, if you do not know, sun is actually an atom bomb that is burning, right? So on Earth, whatever technology we have developed, we can split an atom, right? That is fission. We can split an atom, split a heavier atom into two lighter atoms, and the energy that is residual we are going to get, all right? E is equal to mc square by that. So it will be multiplied by square of the speed of light. So that gives a huge amount of energy. So that is the fission technology. But on sun, fusion happens. That means lighter elements, helium kind of elements, combines and form heavier element, and that is also going to give some energy, because there will be a little bit of deficit of mass, very small but sufficient for you to get a lot of energy. So that reaction is going on sun continuously. So over time, every star will die out. Sun is also a star, right? So after that, life for us will not be possible. Why? Because we are developed in that manner that we need light, we need air to breathe, we need oxygen in a particular amount. So it will not be habitable for us. It is a completely different deal if we develop according to that, or we adjust according to that, or our generation or genes develop according to that. Because sun is dying out, and it is not going to happen over few hours, right? It is going to take years and years, and maybe we'll be accustomed. But yeah, after some time, it is going to completely wipe away. So that is the source of all the energy that we are having. If that is gone, then the life on Earth is gone. So till then, we have to find some other place. Maybe Elon Musk will be helping us. All right, next. Is that time dilation is really real? See, it is a topic that I'm going to talk properly about it someday, about theory of relativity and all that. But it was very interesting the way Einstein talked about it. All right, now this is how Einstein actually started his study, or got a key to his study of theory of relativity. This is how the legend goes. Einstein was there with his friend, and he was looking at a clock, right? At a clock tower, and it was somewhere around, I would say, 900 meters away. Okay, he was standing on a cliff, and he was looking at a clock tower. And he said that if I look at the same time, there's a clock on my watch, and let us say it is 12 o'clock, and there's a clock on the clock tower, and it is saying 12 o'clock. All right. Now I look at here. Now the light has to go from somewhere to the clock, and then it has to come to my eyes, right? It is going to take some time, all right, even though light is very, very fast. But when you talk about the grand scheme, when the big universe comes, the speed of light is also not that much. So it is going to take some time for me to see the clock, and it's going to be much faster when I'm looking at the wristwatch, because the distance is very small. But the distance from me to the clock tower is, let us say, 1 kilometer, is far, all right? And by the time the light hits that clock and comes to me, maybe the time is not 12 o'clock anymore, all right? Maybe the time is 12 o'clock plus a fraction of second. So there's a lag between that time that I'm able to see and the time that I'm seeing on the clock. So that is very, very interesting, right? That is the birth of theory of relativity. So see, the whole rocket science, the entire rocket science, and everything that you'll need to study, everything can be given by Newtonian physics. You'll need the laws of motion, and you'll need all the things that Newtonian physics talks about, right? The only place where the rocket science is going to need the Einstein's physics, that is theory of relativity and all, is the atomic clock that is going on in the satellites. So how do you think GPS works? So let us talk about how GPS works. So what is the task of GPS? GPS has to locate me. Where am I right now? And for that, I'm having a cell phone, and cell phone is going to give some signal. It is an electromagnetic wave. Again, it's going to have the speed of light. It's going to have a speed of 3 into 10 to the power 8, right? Okay, now this is how it works. That is going to transmit a signal. The satellite is going to transmit a signal. It's going to come to my cell phone, and then it's going to bounce back, right? The time between that signal leaving the satellite and then reaching back, that we know, all right? Transmitter, receiver, we know the time in between, all right? And the speed, we already know what is going to be the speed of transmission of that wave, we know. Then obviously we can find out distance or not, right? So obviously only one satellite cannot do, and we'll need constellation of satellites for that. But this is the simple principle of how you locate someone somewhere, right? So that time, the time that it takes, actually time is going to have variation because of the gravitational field. That is what Einstein gave. So the time that is going on the Earth's surface is not going to be exactly the same as the time going on in ISS. It is not a very remarkable difference, but when you come to very accurate measurements, then it is going to matter. And that adjustment of the atomic clock that is present on the satellite is going to take care of that using the Einstein's theory. So that is the only place where Newtonian physics is not sufficient. All right. So I'm going to talk more about that in some particular video, but I'm sure that it is very, very interesting for you guys, right? Okay. Next, from where the dark matter arrived. I have not studied dark matter sufficiently, so I cannot talk about that. Can we call time as the fourth dimension? No, we can definitely. Time is definitely the fourth dimension. All right. So the 3 dimensions are X, Y, and Z, the coordinates that we work, and 4th dimension is time. There's no doubt about it. The total 11 dimensions, and that's where the string theory and all starts. So that is also very interesting. So definitely yes. Next question. How was the space before the Big Bang? That is like an abstract question. I cannot know. I do not know even if the top scientists know. But there are various theories. That is also infinite. All right. Everything in the universe is infinite. There's also a theory that at the center of every black hole, what we call singularity, there's a theory that the center of black hole is another universe, with again a black hole at the center of that universe. At the center of that black hole is again a universe that is going to go on till infinity. That is the meaning of infinity. So infinity is in every sense, in the space domain and the domain of fucking your mind up, right? So okay, I don't know global Pete. If suppose universe consider as a sphere, what's there beyond that? Okay, now I understand the kind of questions that is coming from, and this messes everyone's mind. All right, and it's supposed to, like, we say, okay, where are you, Ashish? I'll be saying I'm in Bangalore. Where is Bangalore? That's in Karnataka. Where is Karnataka? That's in India. Where is India? India is on Earth. Where is Earth? Earth is in solar system. Where is solar system? Solar system would be in Milky Way galaxy. Where is Milky Way galaxy? It would be in universe. Where is universe? I don't know. Right? That is the problem. We don't know where we are and what is holding this universe, or where is this universe. That is, I think, infinity. Okay, and I do not think that I'm the person who can actually talk about this. I do not think that there's anyone who can talk about it with certainty. And that's the beauty of space technology. That's the beauty of studying this domain, that it is infinite. No matter how much you study, you will always be pioneer, because there's no end. So if you have to travel from 1 to infinity, okay, you might be saying, okay, let us talk about this in the way of time. Let us say that you started at 1 AD. All right, let us say that the time starts from there, but time is going to go till infinity, right? So they might say that from 1 AD to 2000 AD will be the founding members. They were the initial people who actually formed the mankind and the community that we are having. All right, so compared to what? Compared to maybe 5 million, but compared to 5 billion, even the first 10,000, 20,000 years would be the initial years, right? So if you do not know the end, you cannot say what is actually the pioneer part. So people who are actually right now doing breakthroughs in this domain just might be the pioneer, all right, compared to people who are going to do later. And the later phases also, since it's never going to end and the universe is infinite, we all are pioneers. I do not know if you got the point properly, but these are the thoughts that used to go through my head long time back. Okay. Next, what is meant by big RIP? I do not know what you're talking about. Maybe I'll have to study. If you guys have some ideas about these things, know that these questions are interesting, you can put it down in the comment section. Last but not the least, do aliens exist? Yes, I've talked about this in the Momentum podcast, so I'm not going to repeat myself. I think it is available on Instagram also. But thanks for the questions. Global Feed, I do not know your name. I know that you're a frequent follower of this channel. But there's few more questions. And I think Sanket Chabre also asked the same question about aliens. But I've already talked about that. I'll link it down in the description box so that you can find that podcast. All right. Now, few more questions by Bharat Suresh. Okay, maybe it is Bharat, but maybe it is Bharat. Now, why everything in space is arranged in 2-dimensional, like solar system is almost 2D, except Pluto. Milky Way galaxy is 2D. See, you cannot say it is 2D, especially because I'm 3D and I'm within Milky Way galaxy, right? So it is flat, that you can say, or you can say that the thickness is less compared to the size of it. All right, first of all, I do not think that everything is 2D in solar system. There will be slight variation in the orbits of various planets. Yes, the only thing is that Pluto is having a very large variation, right? But still, so you can actually have an orbit which is at an angle. For example, right now we were talking about that, SSTO. All right, so you can have a polar orbit. So for example, Earth is spinning like this and it is revolving like this, but still you can throw something out and it will have an orbit like this. All right, or if you throw it with a higher velocity, then every planet is rotating, revolving like this, but you can have an orbit like this. There's absolutely no problem about it. You can have an orbit at any angle. Like I said, I've talked about this in my KSP walkthrough playthrough also, that the gravitational field acts in all the dimensions, right? So the orbit can be formed in any dimension, and it is not perfectly 2D, it is 3D. But why is it flat? That is a good question, but I do not think it is perfectly flat. All right, so if you go to multiverse and all that, you will be seeing a lot of spherical universe shown in a spherical manner. So I do not think it is 2D. All right, next, if planet is in opposite side of the sun, all right, why don't we use sun's gravity and take a slingshot to reach there instead of waiting it to be near? Now I could not understand properly. If planet is in opposite side of the sun, this is the sun, this is the planet, why don't we use sun's gravity to take a slingshot to reach there? Or wait, okay, I did not completely understand the question. I don't know if you 100% know what a slingshot is, all right? So that is why I love KSP, because I've shown so many things in the orbital mechanics domain over there through that game, because it is a simulation game. So a slingshot, an orbit, is that you have to reach close enough to a planet or other celestial body, and then again decrease the apogee or apoapsis in certain manner that you are forming an orbit. If you do not decrease the apoapsis is at infinity, and you are going to get influenced by the gravity and again going to tossed away in other direction. So that maneuver is actually used a lot in interplanetary. We have sent a probe, no, it is Voyager 1, that has actually crossed Pluto also. So it actually used a lot of slingshot, and you have to if you're traveling that big of a distances, right? So I'm not clear about your question, but can we use the slingshot of sun? See, we can, but we are already in the orbit of sun, right? So we are already orbiting sun. So what happens now, what we need to do when we reach at the periapsis, that is the closest point to the sun. Right now the apoapsis and the periapsis of the sun, of the earth, would be very, very equal, all right? No, I think it is a little bit different. It is an elliptical orbit, so the periapsis is going to be closer. So when we reach at the periapsis, at that time, let us say that earth is having a big gigantic rocket booster and is going to fire prograde, right? So in the direction in which it is moving, the opposite to that, if it is thrusting, right, that means trying to move faster in that direction, then what will happen? The apoapsis will keep on increasing, and if you keep on increasing so that it becomes somewhere like it reaches infinity, then the earth is going to have a slingshot and it's going to tossed out of the solar system. So that can be used to do, you can do that with any other rocket as well. If you are in an orbit around sun, if you are already in an orbit around sun, then you'll have to wait to reach to the perigee and then fire in prograde as much as possible so that you escape the orbit, and then you'll go like a slingshot. So slingshot is a way in which it is generally used to just get influenced by other celestial body. Okay, I hope I was able to make myself clear. When we approach a celestial body with our satellite, why we approach it towards equatorial axis and not any other? I am not very sure about that. See, Bharat, it is not true. All right, we do not always approach equatorial axis. It is easy most of the time to approach equatorial axis. For example, Chandrayaan 2. What was that? We are not trying to have equatorial axis over there. We are trying to go north-south. All right, we've tried to land in the southern pole, right? So it is not necessary. We can go anywhere depending on where we want to go. For example, an alien wants to land on Earth, but it wants to visit Siberia, then it is going to need to have an orbit in that direction. And then when it is right above Siberia, that's when it needs to thrust down. Actually, it's going to be much more difficult. So it is going to need a larger orbit and then thrust down, because the Earth is having an atmosphere. So you are having a proper orbit, and then right when you are above Siberia, then what you need to do is fire retrograde, and then you are going to have a good projectile, and you're going to have a vertical motion, and hopefully you'll be having proper thermal shielding and then you'll be landing with proper parachutes, or depending on whatever technology that you're having. Okay, so that's about it, guys. I answered all the questions that you asked related to space technology. I hope that it was interesting. I do not know, let me know down in the comment section what you feel about that. And the audio version of these podcasts will also be available on Google Podcasts, Spotify, Anchor, and I'm thinking of putting it soon on iTunes as well, so that you can get the audio version, you can download it, you can listen to it whenever you're free, whenever your ears are free. And that's about it, guys. I hope that you had fun. And any more questions, the video version on YouTube. So if you want to put the comment, your questions, you want me to discuss that, put it down in the comment section. That's about it. See you next time. Till then, bye.